Hey guys, today we're gonna melt some ice. But wait, hear me out. We're not just gonna melt the ice, we're gonna do something really crazy and measure it. All right, I've got 100 grams of water in my calorimeter. Remember, this is a calorimeter, and it's at 55 degrees, okay? So it's nice and warm. Put it in the microwave for a couple seconds. I've also got 50 grams of ice right from my freezer, and I'm going to take this and dump it into my water. Get that in there, and we're gonna stir it around and let it melt. Here it is melting, just about fully melted there. So what happened here is that the hot water provided some heat to the ice and got it to melt and raise its temperature up to 15.5 degrees. The ice absorbed the heat as it melted because melting is an endothermic process. By my rough calculation, the hot water, as it went from 55 down to 15, lost about 16,000 joules of energy. Okay, that energy went away from the hot water and it went somewhere because energy has to go somewhere. By another rough calculation, the ice itself, the 50 grams of ice, only gained about 4,000 joules of energy as it goes from 0 to 15. So what happened to the other 12,000 joules? It had to go somewhere, right? The law of conservation of energy says energy can't be created or destroyed. You can change its form, it can move from place to place, it can get transferred from one thing to the next, but it can't just disappear. So where did it go? Turns out, in order for the ice to be able to go from 0 up to the final temperature, it actually has to melt first. And that melting takes extra energy. The molecules of the water, which are stuck together and they're attracting to each other, actually have to break apart from each other to be able to move around in the liquid phase. And that requires extra energy, and we call that energy the heat of fusion. The heat of fusion for water is about 334 joules per gram, which means that every gram of ice that needs to melt has to absorb 334 joules in order to do that. Melting is an endothermic process. Energy has to go in for the substance to break apart its molecules and melt. A similar thing happens when you boil water. The water temperature rises, and then it gets to 100 degrees and stops. You could still be adding heat, but the temperature doesn't change. That's because at that moment, the phase change is going on. You're breaking apart the liquid molecules, which are next to each other, and giving them enough energy to go into the vapor phase so they can fly around your kitchen. That extra energy is called the heat of vaporization for water, and it's even bigger. It is about 2,260 joules for every gram of water that needs to vaporize. So there you have it. You can have a temperature change, you can have a phase change, but not both at the same time. Extra energy is required for those phase changes.